Today we are given a list of n minus 1 integers, and these integers are in the range of 1 to n. There are no duplicates in the list, one of the integers is missing in the list, and we need to write an efficient code to find the missing integer. So for this problem, we have our array nums with our 3 integers, 1 missing. We can already see that the 1 missing is 2, but we want to write some code that will find it. So we'll go ahead and declare a new variable called sum and define it as 0. And this is going to be trying to keep track of the sum of the array, including what we assume the missing number is. And then we'll also declare another variable called numsbase. And this will be defined as 0. It will be used to keep track of the sum of the actual numbers existing in our array right now. And we're also just going to go ahead and create another variable n, which will keep track of the length that we would want our array to be. This will just help us in making our for loop. So we'll do nums.length plus 1. And then we'll go ahead and start making our for loop. So as usual, we'll set I to, let I equal 0. And to give us more room to work, we're going to go ahead and just let I go lesser than and equal to the n that we set. And we're going to put an if statement in there to control the iteration for numspace. We're going to also have I increment on every iteration. So for this larger loop, we're going to let sum be changed to sum plus I on every iteration. And then we're going to create an if statement so that numspace only changes. And part of this, we're going to set it equal to I less than nums.length. And this way we can keep just one loop. So in this section, numsbase will be redefined as numsbase, whatever it currently was, plus the current index of nums as it iterates. And then we'll close that if statement and close our for loop. So what we want to be able to do to keep track of what our, as we said, our missing number is, the way we'll find it is by console logging sum minus numspace. And now we'll switch colors and we'll just walk through the for loop. So through the for loop, you can see that the definition of sum is going to be changing and the definition of numspace is going to be changing. So on the first iteration, we have sum equal to 0. We're going to add sum, which is 0 plus I. At this point, I is also 0, so sum is just going to equal 0. And just to be clear here, n equals nums.length plus 1. So that's going to be 4. We're going to go on 4 iterations through for sum. So that's the first one at 0. And then for the second one, sum still equaling 0 plus I, which is now going to be 1, is going to change the definition to 1. And then we're going to add 1 to 2, which is the next iteration of I, which will make sum 3. And then we'll add sum, which is now 3, to 3, which is the next iteration of I, making sum equal to 6. Finally, we're reaching the value of n for I, so it won't go any greater than this. Sum equals 6, I equals 4. We're going to add 4 to 6, and sum will equal 10. And then we'll go through and discuss numSpace. So numSpace is only going to be going up to less than nums.length. So it's going to have up to less than 3 iterations. So numSpace starts at 0, and its definition is itself plus the first value in the array, which is 1. So it will automatically change to 1. Then on the next iteration, it will add itself 1 to the next iteration in nums, which is 3, making it 4. Finally, it will add itself 4 to the next iteration of nums, which is 4. So numSpace will end up equaling 8. And as we can see, if we were to subtract numSpace from sum, it would equal 2. Let me get to it. It would equal 2, and 2 is the missing number in our array. So that's how you would find the missing number in the array. And as far as time complexity, I would say this is an n squared situation. We have one for loop, although we have an if statement in it, we're not looping through twice. So n squared is the time complexity.